Hello there, welcome to this video. This is 11-3 and we are going to talk about how do we solve non-right triangles. Up until this point, you've had a couple of tools in your tool belt to solve right triangles. You can use Pythagorean theorem, you can use SOHCAHTOA. All those will help you with right triangles. But what happens if I don't have a right triangle? Well, we're going to add another tool to your tool belt today. All right, so if I don't have a right triangle, sine of an angle is not the ratio of the opposite over the hypotenuse side. And cosine of an angle is not equal to the ratio of the measurement of the adjacent side over the measurement of the hypotenuse side. And then the same for tangent. SOHCAHTOA doesn't work. Same thing applies to the Pythagorean theorem. That must be a right triangle. So we cannot use a squared plus b squared equals c squared. So what do I do if it's not right? Well, we're going to go ahead and talk about today the law of sines. And that's our objective. How do I solve a non-right triangle using the law of sines? So here is the law of sines, nice and short and sweet for you. The law of sines pretty much says that if I have the sine of an angle over its corresponding or opposite side, that ratio will be equal to the ratio of sine of another angle and its opposite or corresponding side. So here's the law of sines. We don't have to know everything. You can go ahead and break it down into parts, right? Sine of A over A is equal to sine of B over B, and vice versa too through the transitive property. If I just want to find out maybe something about C or angle C, we have sine of A over A is equal to sine of C over C. That's the law of sines. Very, very simple. A lot of students like doing this. It is very easy and intuitive. Don't rely just on this. You do need to know the sine, cosine, and tangent ratios, know how to utilize SOHCAHTOA. All right. So what happens if I'm given certain information and I want to go ahead and solve using law of sines? Well, here's kind of the step-by-step procedure. You can do this. It's very, very intuitive, so you can pause it right now and read this if you want. But I'll also add in this kind of note here. Avoid using rounded values. Now, why would I want to avoid rounded values? Well, if you utilize rounded values, you're kind of probable to end up with a rounding error, which is no bueno. You don't want that, okay? So avoid using them if at all possible. And most of the time it is possible. Sometimes we'll run into an example today where we actually have to. All right, okay. So here is our very first example, and we're asked to solve the triangle and round side measures to the nearest tenth, and we want to round angle measures to the nearest degree. Okay, so what I'm going to go ahead and do is I'm going to go ahead and color code this, and I want you to see that 35 degrees here corresponds to this side, 15.0. So if I'm setting up, if I want to go ahead and solve utilizing the law of sines, I know that this ratio, sine of 35 over 15, is going to be equal to, okay, well, what else am I given? I'm given 38 degrees is here, okay, and what's its corresponding side? Well, it's directly across from this side, and I'll say little s. So then it's equal to the ratio of sine of 38 degrees over little s. Okay, so what? Well, go ahead and solve for s. That'll give you the side. And now how do we do this? We're going to go ahead and cross multiply. That's the trick with these. Okay, and we will get s. We'll make sure that that's a s. I have a lot going on here. S sine of 35 is equal to 15 sine 38. Okay, I want to solve for s, so I will divide each side by sine of 35, divide by sine of 35, and we get s is equal to 15 sine of 38 over sine of 35. Okay, and that is approximately 16.1 units. And ta-da, that is the law of sines. That's how you use it. Okay, so I know that S over here, I know that S, this is 16.1. All right, what am I missing? Well, I'm missing angle T. Okay, so if I want to find out the measurement of angle T, well, that's equal to 180 degrees minus 35 minus 38 degrees. Okay, so that would be equal to 107 degrees. And there we have that. So 107 degrees. All right, cool. We're well on our way. Now all we have to find is the side opposite of angle T, which is little t. So how are we going to do that? Well, law of sines. And again, avoid using rounded values. So I don't really want to touch that 16.1. It's rounded, it's approximate, it's not exact. So I'm going to go back to my initial setup of sine of 35 over 15 is equal to sine of 107 over t. Okay, and then we're going to go ahead, we'll cross multiply and solve. And that's pretty much it. So t sine 35 over, not over, t sine 35 is equal to 15 sine 107. Okay, and I can go ahead and divide, and we get t is equal to 15 sine 107 over sine of 35. Okay, and this is, those are some pretty ugly approximates. Approximately 25.0 units, right? Round to the nearest tenth. Ta-da! And that's it. Okay, so let's summarize all of this. I had S is approximately 16.1 units. I knew that T is approximately 25.0, that's a 6, units. And the measurement of angle T is equal to 107 degrees. I have solved a non-right triangle utilizing the law of sines. Ta-da! Right on. Not too bad, right? Okay. All right, let's go ahead. Here is a practice problem. Please pause the video. I want you to solve this on your own, and then unpause me, and I'll show you the answers. Okay, so hopefully you paused it. Ta-da! Here is the answers. Did you get those? I knew you could do it. Good job. If you didn't, pause it, go back and fix it. Okay. All right. So here is another example, and we're asked to solve the triangle. Again, round accordingly. Sides to the nearest tenth, angle measures to the nearest degree. Again, I'll color code. That kind of tends to help. So here's angle C. Notice C is paired up with side 38, right? And in order to use the law of sines, I have to have corresponding sides, right? I can't go ahead and solve stuff if I don't have matching sides. So I have sine of 140 over 38, and this will be equal to, so what else is given? I'm given 25 here. Okay, so I can use this 25 to solve for angle B. Okay, so sine of B over 25, and that's the setup with the law of sines. Now you just have to solve it using algebra. Okay, so I'll go ahead, I will multiply by 25 on each side, multiply by 25, and we get sine of B is equal to 25 times the sine of 140 over 38. Okay, now I want to go ahead and I want to solve for B. So how do we undo trig? Well, we have to utilize inverse trig, right? So I'm going to take sine inverse of this side and take sine inverse of this whole side. And what we end up with is the measurement of B will be equal to sine inverse of 25 sine 140 over 38. There you go. Okay, and this is, I'm struggling with my approximate signs today. It is approximately 25 degrees. Sorry, I forgot to mention this. If you're not getting this, if your calculator is not cooperating, make sure that you are in degree mode. You have to be in degree mode, okay? So go to your settings, wherever that is, whatever calculator you're working with, make sure it's degree mode. Sometimes you'll see it abbreviated on your screen to DEG. That's how you know you're in degree mode. Radians, you'll often see rad. You don't want to be in radian mode, degree mode, okay, for these, because we're working with degrees. Okay, so that's 25 degrees, and I'm going to drop that in here. Here's 25 degrees. Okay, so all we're missing now is angle A and side little a. Okay, so can't I figure out the measurement of angle A by taking 180 degrees and subtracting 140? That leaves me 40 degrees. Subtracting 25, that leaves me 15 degrees. Ta-da! There it is, 15 degrees. And I know that 25 degrees is approximated. This is actually a low rounding, right? So 15 is slightly approximated, but there's no way around it. I can't utilize law of sines to help me find A. It's a little approximated, so I know it's rounded, but that's just the way it is. Okay, next, we're going to go ahead and find side little a, again, using our initial setup. Right, so I initially knew that sine of 140 over 38, that ratio can be used with law of sines. So I set this equal to sine of 15 over a. Okay, and I have to go ahead and solve this. So we get a sine of 140 is equal to 38 sine of 15, which I'm going to go up here, and we get A is equal to 38 sine 15 over sine 140. Okay, which is approximately 15.3 units. All right, so there's A. A equals 15 approximately. A is approximately 15.3 units. Measurement of angle B is approximately 25 degrees. And the measurement of angle A is approximately 15 degrees. All right, there you have it. Okay, here is the last practice problem. Please pause the video, try this example. I'll show you the solutions. Good luck. All right, hopefully you paused it. Did you pause it? Did you really? Make sure you pause it. Pause it now. Good. Okay, here's your answers. All right, check your work. Measurement angle A, 43 degrees. Measurement angle B, 104 degrees. And the measurement of side B is approximately 21.4 units. These problems all said units. If your problems drop in inches here, then make sure your units are appropriate, right? If you're talking millimeters, drop in millimeters. So something to be aware of. Okay. All right, remember, if I have corresponding information, if I have an angle and a side across from it in a non-right triangle, I can utilize law of sines. Sine of A over A equals sine of B over B. That's it. I'll catch you next time. Be safe, be easy. Peace.